I am Gayatri, working as assistant professor in EC department at SNS College of Technology. Today I am going to discuss about the subject circuit analysis and devices, the unit 1 mesh and node analysis of electric circuits. I am going to discuss about the topic of basic concepts of electric circuit. The overview: today I am going to discuss about the units and scales of electric circuits, charges and current, voltage and power. Charge, the one of the most fundamental concept in electric circuit analysis, is that of charge conservation. There are two type of charges. First one will be our positive charges and second one will be negative. The first positive charges will be represented as proton and negative charges will be represented as electron. There are many devices in which positive charge motion is important in understanding internal operations. But external to the device, we typically concentrate on the electrons which will flowing through our connecting wires. Although we continuously transfer charges between different part of circuit. The charge or SI unit and representation. In other words, the charges can be created, not destroys electrons or protons when running through the electric circuits. The charge in motion represents the current. The SI unit of the fundamental unit of the charge is the coulomb, which is represented in C. The quantity of charge that does not change with time will be typically represented by Q. The instantaneous amount of charge is commonly represented by the term Q of t, or simply it will be represented as Q. The definition of the current using charges: it is defined as a part of ampere by counting a total number of charges passing through the cross section of wire during the interval of 1 second. Current, the idea of transfer of charge or charges in motion, is a vital important to us in studying electric circuits. In moving a charges from one place to another, we may also transfer energy from one point to another. This process of basics of communication system, which will be employed in radio, television and telemetry system. The current present in the discrete path has to be both numerical and as well as it will be associated with the direction which is present. Then the current, which will be represented in the ampere, the SI unit of the current will be the ampere and will be named after AM, ampere, the French physicist. 1 ampere equals 1 coulomb per second. The types of current will be direct current, sinusoidal current, exponential current and damped sinusoidal current. Voltage. The voltage across the terminal pair is a measure of work required to move charges through the element. The unit of voltage will be volt and the 1 volt is same as 1 joules per coulomb. The voltage is represented by V or small capital V or small v. Voltage can exist between the pair of electrical terminals whether the current flowing or not. According to the principle of conservation of energy, the energy is expended in forcing charge through the element must appear somewhere else. The sense of the voltage will be indicated by plus and minus algebraic sign symbols. The sign of the voltage terminal. The terminal B is 5 volt with positive with respect to A. Where in a figure C and D, the terminal A is having the voltage of 5 volt positive with respect to the terminal B. The sign of the voltage terminals, where the in a figure A and B, these are the inadequate definitions of the voltage. And C, which will be a current definition, includes both the symbol for variable and the plus and minus symbol pair will be represented in terms of voltage terminal. Power. If any 1 joule of energy is expended in transferring 1 coulomb of charge through the device in 1 second, then the rate of energy transfer is 1 watt. The observed power must be proportional both to the number of coulombs transfer per second current and to the energy needed to transfer 1 coulomb through the element voltage. Thus, the power will be represented in terms of voltage and current. P, which is equal to V into I. Voltage and current sources. Using the concepts of current and voltage, it is possible to specify in defining the circuit element. All the simple circuits elements are classified according to the relationship of current through the element to the voltage across the element. The sources which are defined as independent source and dependent source. The dependent source will be classified into current controlled current source, voltage controlled current source, voltage controlled voltage source, current controlled voltage source. The assessment: which of the following is not expressions for the power? P, which is equal to V into I, it is a current definition for power. P, which is equal to I square into R, which is correct. P, which is equal to V square by R, and last P, which is equal to I into R, which is the not expression for power. The symbol for used for representing independent sources was circle. Thank you.